So in this video, we will talk about algebra of matrices. So now we're gonna kind of put a little bit to rest on the Gaussian elimination for now until we get to inverse matrices. And now we're gonna consider just a general matrix. So we're gonna call m by n matrices, or an m by n matrix, just an array. So an m by n matrix is just an array of numbers with m rows and n columns. So basically what that means is that if you have an m by n matrix, m by n, so the way that we write it is m by n, the m represents the number of rows, and then the n represents the number of columns. So that's kind of how we have interpreted to be. So remember, rows are horizontal, columns are going to be vertical. So usually the way that we write a matrix, we say that this would be A11, A12, A13, all the way until I get to A1n. So basically what this means, the first one is row 1 and then column 1. Row 1, column 2. Row 1, column 3. Row 1, column n. This is the last column. And then I can do the same thing to A21, so second row, first column, third row, first column, and continue on until I get to the mth row, first column. And then I can do the diagonals, A22, that's second row, second column, third row, third column, and continue on until I get to the last one, mth row, nth row. So this is what we call an m by n matrix. So whenever we talk about dimension, if I ask you what is the dimension of the matrix, it would just be m by n. Okay, so for example, let's say I gave you this matrix. So let's say I said 1, 3, 0, 2, 4, negative 1. So what would be the dimension of this matrix? So the dimension of this matrix, you have to first count how many rows you have. So you have 2 rows. So it's going to be a 2 by how many columns? So in the columns, you have 3 columns. So it's a 2 by 3. Okay, so that's what that's going to be. All right, great. So now let's look at different things about matrices that you can do. So the good things, some of the algebra that you can do with matrices is that you can add, subtract, and multiply matrices. So you can add, you can subtract, and you can multiply. Okay, so you can do all of these different things with matrices. Now the thing about the addition and subtraction, you need to make sure that matrices must have the same dimension. Because if you don't have the same dimension, then in that case, you're not going to be able to add all of them together. So let's say, for example, I give you a couple of matrices. So let's say A is equal to 3, 2, 1, 4, 0, 1. Then you have matrix B, which is negative 3, 0, 2, 1. And then you have matrix C, which is 7, negative 1, negative 8, 0, 0, 4. Okay. So let's say I gave you these 3 different matrices. So let's say first I want to ask you for the dimension. So what are the dimensions of all of these matrices? Well, the dimension of A, okay, for A, what would this be? Well, it would be 3 rows and then 2 columns, so it's a 3 by 2. This one, there's 2 rows and 2 columns, so this is a 2 by 2. Here, there's 3 rows, 2 columns is a 3 by 2. Which means that when you do this, these 2 are basically the only ones that you can do, perform an addition or subtraction. So let's say I wanted to figure out what A plus B is. Well, this is actually really easy. So the way that we add the matrices is just, we basically just add each entry. Okay, 7, negative 1, negative 8, 0, 0, 4. So all we just got to add is just add each individual I was going to say component, each individual entry. So 3 and 7 is going to give me a 10. 4 and -1 is going to give me a 3. Then 2 and -8, that's going to give me a -6. 0, 0 gives me a 0. 1 and 0 gives me a 1. And then 1 and 4 gives me a 5. So this is going to be the solution to that matrix, the addition. What about if I did A minus B? Okay, well, in that case, you're going to have exactly the same thing, but now you're just going to subtract everything from it. So 7, -1, -8, 0, 0, 4. So 3 minus 7 is going to give me a -4. 4 minus -1 is going to give me a 5. 2 minus -8 is going to give me a 10, then a 0. Then 1 minus 0 is going to give me 1. 1 minus 4 is going to give me -3. So hopefully I did that right. Okay. Is it possible for me to add B plus C? No, I can't, because notice if I look at B and C, if I were to add them, I would only be able to add the first two, but then I don't have anything else. So this one actually, because the dimensions are not the same, is impossible. So you cannot do that. Okay. One thing that you can do, and that kind of brings it based on this, is you can do something called scalar multiplication. So this is very similar to vector multiplication. So all you have to do is you can just multiply K times the matrix. So let's say you have A11, A12, A21, A22. And if you multiply it by a number, all you're just doing is taking K and multiplying it by every single entry. Okay, KA12, KA22. So that's basically what you're doing. You're just distributing that K into the matrix. So can you tell me what 2 times A is going to give me? Well, 2 times A basically means that you're taking 2 and you're multiplying it by A. 3, 4, 2, 0, 1, 1. So I'm still using the same problem from the previous one. So this is just going to be 6, 8, 4, 0, 2, and 2. So you're just multiplying them and then just getting that. Okay. Now, matrix multiplication is a little different. Okay. The way that we talk about matrix multiplication, so when we talk about matrix multiplication, it's going to be a little different because you're basically doing something called the inner product. Okay. So the way that matrix multiplication works is that you're going to multiply the two matrices together. Now the dimension here kind of does matter. The way that you're going to do it is you're going to take one of the rows, which is, let's just say this is the ith row, and multiply it by one of the columns. Let's just call that the jth column. Okay, and the output is going to be, so basically you're taking the multiplication of these two things and you're going to add them up. So imagine that you're taking the dot product. And whatever you get is going to be that entry. So this entry right here, which you're going to call Cij, is the ith row, jth column entry. So that's what's going to happen. Okay. So typically the way that you want it to do, if you have an m by n matrix here and n by n, so basically what you're really looking for is that you're looking for the inner parts. So see, this guy has n columns, this guy has n rows. As long as these middle parts are good, then you can do matrix multiplication. If they're not, then you cannot do matrix multiplication. And you'll immediately know once you start doing the problem. So let's say, I'm going to give you an example just to showcase this. So let's say A is equal to 1, -1, 3, 0. And then you have B is equal to -1, 0, 5, 4, 2, and 7. So let's say you have something that looks like that. Well, the way that this is going to work is we have to first figure out if this is going to be a correct if you can even do matrix multiplication. So this is a 2 by 2. This is going to be a 2 by 3. Notice that even though the dimensions are not the same, you're just looking at the insides, 2 and 2. They are equal to each other. That means that you can do matrix multiplication. Okay, so the way that we're going to do this, we're going to do A times B. So you're going to take 1, negative 1, 3, 0, and multiply this by negative 1, 5, 2, 0, 4, 7. Okay. All right, and this is how matrix multiplication is going to work. You're going to go each row and then each column. So first, let me make a big matrix here. You're going to take this row and multiply it by the first column. And what you're basically doing is you're taking the dot product. So remember, the dot product was you take the first entries, 1 times negative 1, that's going to give me negative 1. You're going to add it to the second one, 3 times 0, that's just going to give me 0. That is the first entry. Okay? Now you're going to do the same thing. So still same row. And now you're going to go to the next column. So 1, 3, and now you're going to go to this next one. So it's going to be 1 times 5, which gives me 5. And you're going to add 3 times 4, which is going to be 12. The product between the two. We're going to do the same row, multiply it by the next column. So 1 times 2 gives me 2. Then 3 times 7 gives me 14, so plus 14. Good. And now that we're done with that, we're basically done with the first row. So now we're going to go to the second row. Okay, and we continue going. So if you had multiple rows, you would keep going. And we're going to do the same thing. So negative 1 times negative 1 gives me positive 1. And then 0 and 0 is just going to give me a 0. So same row again. Now the next column. Negative 1 times 5 gives me negative 5. 0 times 4 is just going to give me 0. And then you're going to do the same thing, negative 1, 0 with 2, 7. So that's going to give me negative 2 plus 0. Okay? And all we're going to do now is just add the numbers together. So this is negative 1, that's 17, that's 16. That's going to be 1, negative 5, and negative 2. So this is going to be my solution. Okay? So a little tedious. You're doing the dot product. You're taking the vectors. You're basically multiplying them together. Notice that the output is a 2 by 3 matrix. Could we have known the dimension from the very beginning? Yeah, we could have. So notice when we were looking at the insides, the outsides number, so if the insides are the same, you can do it. The outside numbers are going to be the dimension that we get. So a 2 by 3. That's how we know. Now the thing about matrix multiplication is that it's not the same if I flip it around. If I put B times A, then basically what that means is that I'm going to multiply B, negative 1, 5, 2, 0, 4, 7. I think that's what it was. Was it that? Yeah, okay. And then you're going to multiply this by A, which is going to be 1, 3, negative 1, 0. And you can see right off the bat that this is a 2 by 3. This is a 2 by 2. Notice that the middles do not cancel, are not the same. So this is impossible to do. So you cannot do matrix multiplication on this particular problem. So, and you can even do it. So if you try to do row times column, you can see that you don't have enough entries to multiply things out. So this is just impossible to do. Okay, so when you're doing matrix multiplication, this is basically the gist of it. You're just making sure that you can get the dimensions right. You're only looking at the middle numbers, okay, between the dimensions, and then the outside numbers are going to be what you end up, what the output matrix should be.